This is Dr. Brown. In this section, 8.4, we're going to cover trigonometric identities and show how they can be used to simplify trigonometric expressions. Two things we're going to be looking at is use algebra to simplify trigonometric expressions using identities that we know, and then also establish identities. Now, first of all, let's have the definition of what an identity is. Two functions, f and g, are identical if and only if f of x equals g of x for all x, not just some x. For instance, one identity that we know is that sine squared of x plus cosine squared of x equals 1. That's one of the Pythagorean identities. No matter what value of x you put in and then calculate sine squared plus cosine squared, it'll always equal 1. A conditional identity may be true only for certain values of x. For instance, a very simple one, 2x minus 4 equals 0, is true only if 2x equals 4 or x equal 2. That's the only value of x for which this identity is true. Now we're going to look at some identities that you need to remember. There are some identities that I will not require that you remember, but these equations you should know that the tangent function is exactly equal to the sine function over the cosine function. The cotangent function is equal to cosine of theta over sine of theta. And then the reciprocal identities that cosecant of theta is 1 over sine of theta. And the way I remember that is to say that cosecant theta is not going to be equal to 1 over cosine of theta. It's going to be maybe the opposite of what you might think, and put in 1 over sine of theta. Likewise, the secant of theta is not equal to 1 over sine of theta. It's equal to 1 over cosine of theta. And then finally, cotangent of theta is equal to the reciprocal of tangent of theta, which is 1 over tangent of theta. Now the Pythagorean identities are sine squared theta plus cosine squared theta equal 1. Tangent squared theta plus 1 equals secant squared theta. And then finally, cotangent of theta plus 1 is equal to minus cosecant theta. Now, even and odd identities you need to understand. You remember that the sine function looks like this. And so the sine of minus theta is equal minus sine of theta. The cosine function is an even function, and the middle part of it looks like this. So the cosine of minus theta is the same as cosine of theta. The tangent function is just like the sine function in that it is an odd function. Tangent of minus theta is equal minus tangent of theta. And then cosecant theta is minus, cosecant of minus theta is minus cosecant of theta. And secant of minus theta is equal to secant of theta. And then cotangent of minus theta is minus cotangent of theta. Now we're going to show how to use algebra to simplify trig expressions. We're going to do 4 of these. And we're first of all going to simplify cotangent of theta divided by cosecant of theta by rewriting each trigonometric expressions in terms of sine and cosine functions. So now, cotangent of theta divided by cosecant theta. Cotangent of theta is equal to cosine of theta over sine of theta. And cosecant of theta is 1 over sine of theta. And we can simplify this. We can divide by 1 over sine of theta by flipping over the denominator and multiplying. And notice sine of theta and sine of theta cancel out, and we get that this expression equals cosine of theta. Now we want to show that cosine of theta over 1 plus sine of theta is equal to 1 minus sine of theta divided by cosine of theta by, in this case, they're giving us a hint, multiplying the numerator and denominator by 1 minus sine of theta. So let's do that. Cosine of theta over 1 plus sine of theta. We're going to multiply the numerator and denominator by the same thing, 1 minus sine of theta. And we're going to see in some cases this helps a whole lot. Notice that 1 plus sine theta times 1 minus sine theta was 1 minus sine squared of theta. And now we have cosine of theta times 1 minus sine of theta. And notice that 1 minus sine squared is equal to cosine squared of theta. And notice one of the cosines will divide into the cosine squared once, leaving cosine of theta. So sure enough, we have established that this identity is so. Now we have this equal to what they ask us to prove. Now, with this example, we want to simplify this expression, and it says by rewriting the expression as a single ratio. Well, that really means that we want them to have the same denominator, and maybe something nice will happen. 1 plus sine of u divided by sine of u. And if we want them to have the same denominator, we want the first term to have cosine of u here, and we'll put cosine of u here. And then the second one would be cotangent of u minus cosine of u divided by cosine of u, and I'm going to multiply by top and bottom by sine of u so that they now have the same denominator. Now, since I've got the same denominator, I can add the numerators, and let's multiply cosine of u times this term, and we get cosine of u plus sine of u cosine of u divided by sine of u cosine of u. And notice that cotangent of u is cosine of u over sine of u times this sine of u. And then finally, minus sine of u cosine of u. And now let's see what kind of simplification we get. We can cancel the sine u here. And notice we get sine u cosine u minus sine u cosine u. And this is cosine u and this is cosine u. So we get 2 cosine of u over sine u cosine of u. The cosine of u's cancel, and we have 2 over sine of u, which we could leave the same. But remember that 1 over sine of u is cosecant of u, so it should be equal to 2 times cosecant of u. We want to simplify this expression by factoring. And sine square v minus 1 can be factored into sine of v plus 1 sine of v minus 1. And now let's take tangent of v out of the denominator, and that would leave tangent of v times sine of v minus 1. And finally, we have sine of v plus 1 divided by tangent of v. And if we wanted to, we could write this as sine of v plus 1 times cotangent of v. Now, the next thing we want to look at is how to establish an identity. And what we want to do is show that in this particular example, that the left side of the equation equals the right side of the equation. And notice that there are no cosine of negative theta or sine of negative theta on this side. Let's use the even and odd identities for sine and cosine to simplify what we see. Notice that sine of minus theta equals minus sine of theta, and cosine of minus theta is equal to cosine of theta. So now, plugging this into the left side, sine of minus theta is minus sine of theta times sine of minus theta again, which is equal to minus sine of theta. Minus cosine squared of minus theta is cosine of minus theta, which is cosine of theta, times another cosine of minus theta, which is cosine of theta, divided by sine of minus theta is minus sine of theta. And cosine of minus theta is cosine of theta. So, continuing to work with this, we get the denominator or numerator is sine squared of theta and minus cosine squared of theta divided by minus sine of theta plus cosine of theta. And this becomes sine of theta plus cosine of theta times sine of theta minus cosine of theta, and minus sine of theta plus cosine of theta. And notice sine of theta plus cosine theta cancels, and we can move this negative up to the top, and we will get cosine of theta minus sine of theta, which is exactly what we wanted to establish. Now we want to establish this identity by writing 1 plus tangent of u, and then realizing that cotangent of u is 1 over tangent of u, and we can continue to write this as 1 plus tangent of u, and the denominator is, notice that you can multiply this together and get 1 plus tangent of u divided by tangent of u. And finally, we get 1 plus tangent of u times, flip over the denominator, and we get tangent of u, just what we were looking for. Now, we want to establish that the expression on the left-hand side is equal to 1. And what we very often can do is use the fact that tangent is equal to sine over cosine, cotangent is equal to cosine over sine, and secants is 1 over cosine and cosecants 1 over sine, and see if we can establish that identity. So tangent becomes sine of v over cosine of v, and cotangent is cosine of v over sine of v. Divided by secant of v is 1 over cosine of v. Cosecant is 1 over sine of v. And let's now combine all of this. Combine these expressions, we get sine squared of v plus cosine squared of v over sine of v times cosine of v, dividing by 1 over cosine v sine v, flipping it over, we get sine of v cosine of v. And sine of v, cosine of v cancel, and remember that sine square of v plus cosine square of v is 1. So we indeed get 1, as we were asked to prove. Here we want to establish the identity that 1 minus sine of theta over cosine theta equals cosine of theta over 1 plus sine of theta. Well, there is one trick that we had learned but that will sometimes simplify expressions like this. Let's try to multiply numerator and denominator by 1 plus sine of theta. So let's try this. 1 minus sine of theta over cosine of theta times 1 plus sine of theta over 1 plus sine of theta. And this equals 1 minus sine square theta divided by cosine of theta times 1 plus sine of theta. Notice that 1 minus sine square theta is equal to cosine square theta. And a cosine theta cancels out one of the cosine thetas in the numerator, so we get cosine of theta over 1 plus sine of theta. Now, here's some guidelines for establishing identities. First of all, in order to be able to do these, you need to practice and do some homework. Usually you want to start with a side containing the most complicated expression, because usually you're going to do something to simplify it. Sometimes you might want to rewrite the sum or differences of quotients as a single quotient, that is, using one denominator. Sometimes it will help to rewrite one side in terms of sine and cosine functions only. Always keep your goal in mind, and as you manipulate one side of the expression, keep in mind what you would expect to see on the other side. And that is the lesson for today.